Okay, so we've all seen the periodic table, right? It's on classroom walls, it's in textbooks, it's everywhere. But have you ever really stopped and wondered why it has that specific, kind of weird shape? It's not just a random grid. There's a hidden logic, a secret code behind its structure. And in this explainer, we're gonna crack it.
I mean, just look at it. It's probably one of the most famous charts in all of science. But what do the rows and columns actually mean? And what's the deal with those two blocks floating at the bottom? This familiar shape is really a map, and its layout tells a deep story about the fundamental building blocks of our entire universe.
So, let's treat this whole thing like a detective story. We've got a mysterious chart, a series of clues left behind by some brilliant scientists, and a fundamental secret we need to uncover. Our mission? To solve the periodic puzzle. And this brings us right to our central questions. Why this shape? What is the secret code that makes elements with similar personalities, line up in these repeating predictable patterns? To start solving this, we need to meet our first key detective. He's the guy who gets most of the credit for cracking the first part of the code. The brilliant Russian chemist, Dmitry Mendeleev. Now, what's really interesting is that Mendeleev wasn't working in a vacuum. There was actually a German scientist, Lothar Meyer, who was working on a very similar idea at the exact same time. They both saw that a pattern was emerging, but Mendeleev, he took a leap of faith that changed absolutely everything. See, instead of just listing the known elements, Mendeleev focused on their chemical properties, like how they react with other stuff. He arranged them so that elements that behaved in similar ways all fell into the same columns. And here's the revolutionary part. When the pattern told him a piece was missing, he wasn't afraid to just leave an empty space, boldly claiming these were for elements that nobody had even discovered yet. And this is where the story gets just incredible. He didn't just leave gaps. He made super detailed predictions about the elements that would one day fill them. He described their weight, their density, even what color they'd be. I mean, think about it. It was a hugely risky move. If he was wrong, his entire system would just collapse.
And this slide right here, this shows you just how right he was. In 1871, Mendeleev predicted an element he called eka-silicon. He said its atomic weight would be about 72. Well, 15 years later, germanium was discovered. Its atomic weight, 72.59. He was spot on. This was the smoking gun. This was the proof that his pattern was real.
But like in any good detective story, here comes the plot twist. Mendeleev had figured out the what, but not the fundamental why. His organizing principle was incredibly powerful, but it wasn't the deepest layer of the story. Science was about to drop a crucial new clue.
You see, Mendeleev arranged all the elements by their atomic mass, which is basically just how heavy they are, and that made a lot of sense at the time. But it wasn't perfect. There were a couple spots where he actually had to swap elements around, breaking his own rule, just to make the properties fit the pattern. So then, decades later, a whole understanding of the atom itself changed dramatically. First, Ernest Rutherford discovers that atoms have this dense positive center called a nucleus. Then, a brilliant young physicist named Henry Moseley figured out that the true defining property of an element wasn't its weight, but the number of protons in that nucleus. So, this is the crucial shift in thinking. The true organizing principle, the thing that gives every element its identity, isn't its mass, it's the atomic number. And when you reorder the elements by the number of protons, all those little inconsistencies in Mendeleev's table, they just vanish. It works perfectly. Okay, so we know the elements are arranged by atomic number. Great. But that still doesn't explain why the properties repeat in this periodic pattern. To unlock that final secret, we need the master key, a concept called effective nuclear charge, or as we'll call it, ZEF.
So first, let's just nail down this core idea, periodicity. All it means is that as you go up in atomic number, one by one, the properties of the elements don't just change randomly. They follow a repeating, predictable pattern. And that's the very pattern we see in the table's rows and columns.
So what's causing this periodicity? Well, almost all of the periodic trends, why atoms get bigger or smaller, more or less reactive, it can all be traced back to this one single fundamental property, the effective nuclear charge. This diagram of a sodium atom shows exactly how it works. An atom's outermost electron, it's called the valence electron, is in this constant tug of war. It's being pulled in by the positive nucleus, but at the same time, it's being pushed away by all the negatively charged electrons that are closer to the center. We call this push screening.
And that's exactly what Zeph is. It's the net result of that tug of war. It's not the full charge of the nucleus, it's the effective charge that an outer electron actually feels after you subtract all that screening from the inner electrons. It's the true strength of the pole.
And the concept is actually pretty simple. You can estimate it with this formula. Zeph equals Z. That's the total positive charge from the protons in the nucleus, minus S, which is the screening from the inner or core electrons. Since each of those inner electrons basically cancels out one proton's pull, S is pretty much just the number of core electrons. A stronger Zeph means those outer electrons are pulled in way more tightly.
All right, we have all our clues. We have Mendeleev's pattern, we have the atomic number, and now we have the master key of Zeph. It's time to bring it all together and finally crack the code of the periodic table once and for all.
And here's the key. Zeph itself follows a clear periodic pattern. As you move from left to right across a row, Zeph increases, pulling those outer electrons in tighter and tighter. But as you move down a column, the Zeph that the outermost electrons feel stays roughly the same. This simple repeating pattern in Zeph is what causes all the other patterns we see in the elements.
And that is the secret. That is the solution to our puzzle. The periodic table's strange shape is a perfect visual representation of this whole idea. It's a map of the elements, ordered by their atomic number, with the rows and columns laid out so that their repeating chemical properties, which are all governed by Zeph, line up perfectly. It's just a beautiful, elegant system.
So, a complex, almost random-looking chart is ultimately explained by one simple, underlying rule. It really makes you wonder, doesn't it? What other elegant secrets, what other simple master keys are hiding in plain sight, just waiting for us to discover them in the patterns all around us?